Education should prepare young minds for jobs that do not yet exist, using technologies that have not yet been invented to solve problems of which we are not yet aware. With this quote, in this pleasant evening, to refresh and create an impact onto the minds, Department of Electronics and Communication Engineering, Savita Engineering College brings to you a webinar on 5G communications by Dr. V. Prithviraj. Savita Engineering College, established in the year 2001, an autonomous institution which follows the Finland-based education model, and we march towards less is more concept. Our college makes the students job ready by providing Industry 4.0 ready curriculum which imparts the 21st century skills. Project-based learning integrated with subjects improves the student skill set and makes our learners to be the best, which is the motto of our college. The Department of ECE was established in the year 2001. Our vision is to develop the department into a state-of-art with Center of Excellence in Electronics and Communication Engineering education on par with global standards. The Department of ECE has well-experienced faculty of proven ability and diverse specialization. The faculty actively involves themselves in research in the fields of robotics, VLSI, MEMS, image processing, and embedded systems. Professor Dr. V. Prithviraj completed his BE in ECE from College of Engineering, Guindy in 1972, affiliated to Madras University. He subsequently proceeded to Ahmedabad, where he had undergone a specialized PG diploma in the field of space science and satellite applications. Professor Dr. V. Prithviraj received his MS by research degree in electrical engineering from IIT Madras, Ph.D. in electronics and electrical communication engineering from IIT Kharagpur, specializing in signal processing techniques applied to phased array antennas. He has over 3 decades of teaching experience and 12 years of research and development experience between the two IITs in the field of RF and microwave engineering. He had served Pondicherry Engineering College in the Department of Electronics and Communication Engineering for nearly 3 decades from inception and retired as principal in the year 2013. Professor has filed 2 patents, one in the area of cognitive radio and second in the area of quadcopter applications for monitoring the electromagnetic radiations. He has guided 4 PhD scholars, 44 MTech students, and around 125 BTech students during his span of 30 years in the academic field. He has published over 110 research papers and has to his credit 172 Google citations. He is the recipient of the Best Research Paper Award titled COFDM for Telemedicine Applications, selected by the Broadcasting Society of India in the year 2006. He is a recipient of IEEE International Award for Outstanding Branch Counselor in the year 1984 at MIT Manipal. In addition to his academic experience, he had served as an expert member for monitoring Indo-French international projects in the field of information technology. Recently, he was conferred the Lifetime Achievement Award by ISTE Tamil Nadu for his contribution towards technical education during the 20th ISTE Annual Convention. In November 2018, he was appointed as a technical expert to monitor the Smart City project of Government of Pondicherry, and from August 2018, he serves as an Adjunct Professor of ECE Department for Vignan University. We are very proud to have you with us today, sir.
Thank you, Chitra, for that wonderful introduction.
Thank you very much, sir. Now I hand over the session to you. Okay, you can start your presentation. I'll just screen share this. Just a minute, sir.
Can't you go to the slide mode? Yeah.
Right. Yes, sir.
Yeah. Good evening, everybody. It's my great privilege to deliver this webinar on a topic which I thought is of very current interest for researchers as well as the student community. And I'm basically going to present to you on the Phi G communication landscape. But before doing that, I'm looking at some of the challenges which we encounter in wireless multimedia. And then from there, I would then tread very carefully to go into the 5G challenges and how the whole thing gets implemented. Let's go to the first slide, please. Yeah. So multimedia over wireless broadband is an emerging service that integrates voice, video, and data in the providing the same service. And as all of you are very familiar with this particular concept, because we go back to ISDN, from which has basically integrated. ISDN, as you know, is an acronym for Integrated Services Digital Network. And that is where we are able to integrate all these three factors, parameters together. And a very good example for us is our handheld device, just supporting multimedia like the personal digital assistant. Okay? And then we are looking at the advances in multimedia application over the wide area network, and what are the requirements, and how is especially a parameter like quality of service to be taken up. You must be wondering, why did I take up the multimedia aspect here before we go over to the 5G communications? As all of you know that before we come to 5G, we have basically started with 1G, then proceeded to 2G, 3G, and 4G. So if you look at one of the biggest application areas in which 4G has been sustaining all this time is an area of streaming video, and that is one area where the multimedia is getting exploited in a big way. And you would see how once we transit to 5G, how comfortable things are going to be in that frame. Yeah, let's go to the next slide. Yeah, these are examples of multimedia, and you could see the various applications under which this multimedia is basically enabled. And yeah, you go to the next slide. So the major application areas are in remote education, video on demand, tele-shopping, home games, entertainment. Next. So the biggest advantage of this system is it dramatically lower in cost, and it has got this feature of always on, anywhere, anytime, in any form, and voice and multimedia self-service initiative, and simpler to implement for the end user. Next. So now we come to the data side, and this is where I was talking to you about. Especially today, we are in the data services world, as you say, because all of you are realizing now you're using your WhatsApp now, and we have come into a situation where for us, we are more worried about data, so voice is piggybacking on that. Also, you could say that voice is almost coming free of cost for us. And as we look at this data services, I will dwell on this a little further, but you can look at the various applications which are being highlighted in each of the generations 1G to 5G, 4G areas which are being put across. Next slide, please. And this is regarding the WAN air interface based on access technology. And I was telling you 1G, which is predominantly an analog communication system. And this was basically operating the 800 megahertz band. Now we go to the next slide, please. So 2G, which is basically global system for mobile communication, group system mobile, which was prevalent for a very long time, which came in early 90s. And you would find the important thing which came out from the 2G system is the digital voice, and you could see much more increase in the number of channels which were provided as compared to the analog system earlier. And I look into some more details and tell you, because for young students like you, one of the important areas which we keep asking is, why is it that we still retain our GSM phones or our 3G phones? Why is it that people are not throwing it away? What is it, the big? So one of the killer application which we have, the GSM phone, which all of us are, if we keep asking our students, what is the killer application of the GSM phone? You find a lot of students wondering what it is all about. But then moment we say SMS, okay, the short messaging service, which was basically taken up at a very moderate speed of 9.6 kilobytes, and then that gets translated to 14.4. So the SMS is the killer application to sustain the second generation. Now we'll go to the third generation. 3G CDMA, okay, took care of the increase in number of channels and the increase in speeds. We were looking at speeds, data speeds of the order of 2 megabits per second. But one of the biggest differences which we have between 3G and 2G was 3G gave us the opportunity for us to basically look at an application whereby we could not only talk to you on voice, but we could also peruse through an email simultaneously. So 3G gave that. But if one should look at the killer application for 3G, it would be basically with which all you students are very, very happy right now. It is the ability to have internet on your phone. And the other important aspect is, remember, is the modulation technique, which we use in 3G phones is the CDMA technique, in contrast to, let's go to the next slide. Yeah, this is more about WCDMA, the wideband CDMA. And you could see the 3G cellular network and the type of frequencies as usual. The uplink frequency, which is basically from 1885 to 2025 megahertz, and 2110 to 2200 megahertz. Okay, so one of the you could see that the data rate on the uplink. The uplink is basically the link between the mobile phone to the base station. One of the important questions which we always pose to our students is, why is this uplink frequency chosen of this order compared to the downlink? You could have used the reverse link, but obviously you know the advantages which accrue by choosing the uplink frequency to be lower than the downlink band. That is one. And these are all things which have been standardized by 3GPP. Okay, we'll go to the next one. Yeah, this is basically the HSDPA, the high-speed downlink packet access, which is something like a 3.5G type of thing coming up. And here you could see where that increase in data rates on the downlink, which is basically from base station to the mobile, where we are able to look at speeds like 14.4 megabits. And on the uplink, from mobile to base station is 384 kilobits. This is again standardized by 3GPP. Next. Now we proceed to the 4G system, which is basically the long-term evaluation, sorry, for that term. It's long-term evolution. It's a fourth generation cellular network. And immediately I want to draw your attention to the change in the modulation technique which we use. So what is important is we have done a lot of research over a decade, especially at the turn of the century, where 3G came in, that is around 2000 to 2010. All concentration was on CDMA and CDMA evolution. But moment in 2010 when LTE came, it was abandoned for OFDM. Okay, the OFDM modulation technique took over, and along with the support which it had from MIMO, multiple input, multiple output, and this was one which was able to look at speeds of the order of, as it is shown here. That was where it is. Okay, now with this background, yes, let's go to the next one. And these are enhancement which you have to the network. Next. And a couple of major issues which are there on this wireless architecture. Why we are trying to point out is from where, how when we translate to this network, how you will see things are going to be in a much better way. Next. Next. Go to the next one. Yeah. So the various points which we have under the convergence, voice, video, and the smartphone bandwidth. Okay, next. And these are basically the speeds at which we are trying to do this. Okay. And on wireless multimedia, we have adaptive decoding, error resilience, network access, and negotiable QoS. These are the parameters. Next. Yeah, these are basically the data rates, just to show you an idea of it, how much it is. The terabit is the one which is very important for us. Next. So, so in conclusion, we say the quality of video transmission, video transmitted is very high, and real-time transport of data has to be ensured. Problems like jitter are removed. So these were some of the issues. Okay. So with this background now, we now try to proceed to 5G. I now try to introduce some of the major things in 5G. Okay. Let's go to the first slide. So this slide gives you a panoramic view of what 5G and advanced communication systems are. That's basically to give you. And I would basically thank Professor Ashutosh Datta and the IEEE ComSoc Society, from where these slides I have borrowed to share with you. So basically, as you look at the smart variables, smart mobility, smart parking, and we have the classical example of car-to-car communication, the automated cars coming in a big way. And then you have e-health, traffic priority, telematics, connected house, security and surveillance, not forgetting the smart grid. Okay. And then, of course, you have the utility management requirements. So this gives you, you know, what exactly 5G can really be able to do, looking at so many parameters together and trying to offer you that platform. Okay, next. Yeah, so this is that great takeoff slide which I always want to bring to the notice of youngsters is that 1G, which was analog communication, which came in 1980s. And what is important is each one of this generation was for a duration of 10 years, 1G. And then the moment we came to 2G, you could look at GSM right there, right on top there, and the type of data speed. Because please remember, the GSM phone was a voice-centric phone, and it was basically meant for voice. Okay, and you could. It was basically meant for voice, and the data it was able to handle this SMS is at 9.6 kbps, and this was the killer app which sustained the second generation phones, and slowly those levels got scaled up. But in any case, we went through an intermediate stage called the 2.5G. The system which exploited 2.5G was the GPRS, okay, where we're looking at increase in data speeds. But please remember, the other important thing which we want to highlight to our students is basically is a circuit switch network is 2G, 2.5G, and part of 3G was basically a circuit switch type of network, okay, and which was partially packet oriented when we come to, but basically it had. And then moment we came to 3G, okay, the killer application which I mentioned to you was on 3G was because of the availability of internet and the browsing which we could do on that, and we could have data speeds like 2 megabits coming in there, and then there again we found the speeds were not adequate, and then we were looking at uh, how we could increase the speeds to a still greater extent and achieve this possible. So we could see how that translation took place on 4G, and then uh, what the moment we went to 4G, we abandoned all that research which we did on CDMA, which is basically a very good system. You must remember that, a lot of research, but then industry, the moment it looked for a much more efficient modulation technique, it embraced that, and we translated to speeds as high as 100 megabits, which came in 2010. And so that was basically 4G. Now we have entered 2020, where where is the right moment for us to get into 5G. Okay, and we are looking at speeds like 10. In the moment we go to 5G, 10 gigabits further. Next slide, please. Yeah, when you look at key characteristics of 5G, we find that some of the major characteristics of 5G are, which has been enabled, is the massive MIMO, which is come into the network, the radio access network transmission, which takes place both at centimeter and millimeter waves, new waveforms. We have a shared spectrum access, advanced internet coordination, and we have simultaneous transmission reception, and we have a multi-RAD integration management type of requirement, efficient small data transmission, densification of small cells, and then the integration flexible networks. And we have this great area which has to be exploited in a big way in 5G called context-aware networking, information-centric networking. Next slide, please. So the 5G emerging architecture and enabling technologies, we have basically at the yeah At the service level, what is happening, then at the network level, resource and function level, and you could see the 5G new radio, 5G NR it is called. One of the key performance capability which we had was a fiber-like performance. And please remember some of the major attributes which we have in the fiber. And we have two new areas which are covered in this 5G area called network function virtualization. I'll go into more details about it a little later. That means what we have here is the network is realized in software, core and RAN, cloud resources throughout the network, and then we have a programmable network which has got the capability of a flexible orchestration of network resources, the infrastructure, which is both at the radio access network, the core and transport. Then this, I feel, is one of the greatest contribution on the 5G network called network slicing, which is a new term which we use and which has been exploited in 5G in a big way, which basically provides what I call as a self-contained independent network partition, including all segments like radio, core, and transport and edge. It's a multi-domain and multi-tenant type of thing. A good application is today, everybody is concentrating on the urban area networks. And today, if we are rolling out 5G, excuse me, especially in a rural type of network, especially in a rural type of network, we can dedicate a network slice to a particular village, and that would take care of all its requirements. To that extent, we can orchestrate the network and make it sort of self-contained and be independent to take up various applications. A lot of wonderful applications accrue. And this is one area where we want all student members and faculty members to concentrate. A lot of research possibilities is there in this area. Next slide, please. This basically 5G dimensions and types of 5G applications. So as we always say, of course, I have a better diagram in which this would again get depicted in the following slide. But what is important is, since all of us are used to broadband communication in a big way, the moment we come to 5G, we look at its major attribute is enhanced mobile broadband capability, which manifests itself mobile broadband, UHD and high density there, holograms and high mobility, and virtual presence, especially a telepresence application. Then you have it coming in critical communications like interactive games, sports, industrial control, drones, robo and vehicle emergency. Then comes, if somebody should ask me, what then is a good killer application for 5G communications? A very popular questions which is asked to all our students, whether you're appearing for a DRDO interview or an ISRO interview. One of the very popular questions is what then would be a great killer application for 5G would be this massive connections which can be possible. That means with 5G, we say connectivity is the great killer application, and it really exploits in connecting thousands and millions of devices together using the 5G network, especially where we can exploit the Internet of Things because of its wide bandwidth, huge bandwidth which is available. So that then would be a killer application for 5G. So the network operation, here again you find network slicing manifesting itself, routing, migration, interworking, energy saving. So this is something an operator can orchestrate on the 5G network in a magnificent way, basically through the combination of two subsets, I would say, basically network function virtualization, another, I would say, put a slash software defined networking. The combination of NFV and SDN are the two parameters which enable the orchestration and especially the network slicing feature of 5G coming out in a big way. Then, of course, everybody's been talking about this great application called the autonomous driving, enhancement of vehicle to everything, and safety and non-safety features. Because it's not fashionable to get into 5G, but 5G today provides you a lot of safety features which can be easily integrated into the network, and whether, especially when you're giving it in a public domain, safety is of the utmost criteria. And not only that, not only we provide safety, but we also provide a network which is free of any virus. That means it's a very secure network. Okay. Now we come to the next portion here, and this is again depicted by a very fine diagram. And this is where all of us are going to be very happy. Now, we always say, can we put up a battery and shut it up? That means here then is a technique where we have with the in 5G rolling out a AAA battery for next 10 years, operating on the massive IoT requirement. Then we have the network is so resilient, and the available probability is 1 in 10 power minus 5. And speeds like, look at that, 10 gigabits, and that is getting translated to 1 terabit, which is 10 power 12. Massive content can be brought in and massive control. This is another parameter on which I'll be talking to you a lot. Would be one of the great attributes of the 5G network is the response time. Okay, so we'll find the response time because it can be exploited for a lot of real-time applications where one of the greatest attributes is it has a response time of the order of just 1 millisecond. Okay, next slide, please. So now, since we talked about the key pillars of SDN and NFV and 5G security, these are the factors which give that robustness to this network and tells us, look, how beautiful this entire network is, how it can be. So you can see the various factors which are there, starting from the edge security, the cloud RAN, SDN controller security, proactive security analytics, and you could see the various open source, the network slicing security, security function, virtualization, and faster authentication, and especially when you are orchestrating the security features. So this tells you how secure this 5G network is and how is it that it sort of protects this entire network, especially from hackers, which is a big problem which we have, which we have in the earlier networks. This has been thought of very well. So it gives us the robustness which is provided for this wonderful 5G network. Next slide, please. Yes. So this is something which again I want to introduce to the young students is that great contribution of the SDN and NFVs here and is the foundation of 5G. And this is an area which we are getting into in a big way, where we see great opportunities coming up for the youngsters this era, basically the classical network approach, and all of you are familiar with Cisco routers and switches and all that. So today, thanks to this concept of a network function virtualization, what it does is basically all the hardwares are being represented as a virtual software. And today, we can keep this hardware at any particular place, and using the network connectivity, you could have a software virtual, a virtual network uh, providing all the services. Only thing, we'll have to integrate the various software things in a very careful way. And so this particular slide is to characterize all those details here. What is it that we have? And both it has at various aspects of it. So independent software vendors, orchestrated automatic remote install, and the standard high value servers, standard high volume storage. So the network virtualization approach, how exactly it goes about, is a new concept which has to be very carefully understood, and the software uh, IT professionals are implementing have to think it very carefully for them to list out this capability. And this is a great resource which is coming in. And along with the software-defined networking, the combination of NFV and SDN will be able to replace all the hardware with a software virtualized network and still achieve the type of accomplishments which the original hardware network would have done. Next slide, please. Yeah, this is again an overview of NFV network function virtualization. You could see the importance I'm giving to this aspect, because without these tools, the 5G network will not be able to have the versatility which it is now possessing. And these are the major elements which are responsible for it: virtualization of the mobile core, IMS, virtualization of the CDN, and the base stations, and the fixed access. Today, it is able to take on every one of that, virtualization of home and enterprise networks. So you are able to see how this translation from a hardware to a virtualized software is being done. But to put them all in software is of great challenge. And today, our software engineers are really struggling with some of the bigger problems. But then everybody is entering this area in a big way, and so much so that with this virtualized network, we are able to provide either at the edge or at the center, wherever we want, we are able to provide this virtualized network and realize a lot of very good applications of the present state requirement. Next slide, please. So we have the NFV, network function virtualized use case, the virtualization of the mobile core network, EPC and IMS, how this has been done. Okay, IMS is that famous IP multimedia service, okay, through which we are able to interface uh, between two networks uh, to any type of interface which we want to do. And that slide basically tells you how this whole thing is being done. Okay, next slide, please. So yeah, that was my multimedia slides, references. And next reference, can you go? Yeah, next one. Go to the next. Yeah, I would like the references which are made on 5G. No, before that, go to the previous slide, please. Yeah, I would refer to Professor Ashutosh Datta, who has recently delivered the telecommunication seminar on World Telecommunication Day at the Pune University. Please look at that. And this was one of his older presentations, security in SDN and NFV. It's a great presentation. It is available on IEEE on Google, and I would basically acknowledge having taken those slides from his presentation. Okay, now let's go to the next portion now. Yes. Now we come to trying to look at more details about 5G, and I've taken a, a presentation and an implementation scenario which has happened in the University of Malaysia. And thanks to Professor Tariq, myself and Professor Tariq recently were in an international conference at Vignan University, and I had taken his permission to present these slides because I felt it would be very good for the student community to get a complete idea and what it is all about, because 5G is just emerging. So the first question which we would like to ask is, what is 5G? Is it an evolution or a revolution? That is the outline. Then we look at standardization of 5G, 5G spectrum requirements, 5G use cases, and then an application which University of Technology at Malaysia had implemented. So those were the slides which I'm sharing with you. Let's go to the first slide. Yeah. So this is a very important question which I want to draw the attention of the student. So when we went from 1G to 2G, right, we did it in 10 years time, 2G to 3G to 10 years, 3G to 4G to 10 years, 4G to 5G to 10 years. So one of the biggest requirements as we transcended each generation, it took us 10 years. So one of the biggest fallouts of this was, what were the loopholes which were there in the previous generation? Let's say when we went from 2G to 3G, there were some loopholes in 2G which were corrected in 3G. So that means you looked at the network evolving. I repeat, the network was evolving. But when you go from 2G, 3G, 4G, we can say right from 1G, the network was evolving. But the moment we go from 4G to 5G, we say there is a revolution. Okay, it is not an evolution. We'll say it is a revolution. Are we justified in making that statement? Okay, let's go to that slide. Yeah. Okay. So this was basically, yeah, all this happening, digital voice. You have seen this. 4G, 5G. Yeah. Go to the next slide. Okay. So when we look at, so you could see, why did we say evolution? From evolution, we say revolution. Let me take an example. Let's say you're traveling in one of the latest cars, the self-driven cars. They're going on the road. And from that, you will have to take a metro to go to a particular place, let's say for an IT professional. So now, when he travels in this self-driven car, as it is called, thanks to the existing of so many sensors which are located. Those of you who are following the self-driven cars, you will see located in the self-driven car are 6 radars, including a LIDAR, LIDAR. So you would find that all these sensors are together helping the car to traverse that path, and it takes that path where the traffic is least, and it goes to the destination of the metro station. So you would find 5G in combination with this massive sensor, which are located, so many sensors, is helping the self-driven car to go in the midst of a traffic condition and all the protection mechanisms which can be given, and it goes to the metro station. Now, the moment you enter the metro station, right, you're waiting for a metro train to come. It might take a while. So you just press and you would find you are able to access a movie. And you just press that, thanks to 5G, the data speeds it has got, it is able to get onto a movie in a minute. That means you're able to use. So when you looked at the earlier generation, you never had this type of a revolutionary type of things built into that network. That is where we say we have come away from an evolution to a revolution. Okay, this is one example I'm giving you. There are so many other applications which can happen in 5G. So we say 5G is a revolution type of network. It has got so much of capabilities. We'll go to that very important triangle a little later in the slide, which you'll see, which would identify various wonderful applications where 5G can be exploited. Next slide, please. Yes, this is that famous triangle which I was talking to you about. Okay, so this is a triangle which I want all students to concentrate and look at it very carefully. At the top of the triangle, we have the enhanced mobile broadband, and you would find this is where you find gigabytes being provided in a second here, and somewhere in the middle on the left side, you find the smart home building. Today can have a lot of applications coming here. And today in India, we have come out with 100 smart cities. Before I forget, we want young students like you to participate in the smart city project in a big way. So 5G can embrace smart city requirement in a big way. And as it is just entering India, the 5G communications, we can really exploit that for smart city applications in a big way. And at the end of this side, you will find the one I mentioned was the massive machine type communications, which are possible thanks to the IOP, which is being provided and in a big way. As I said, uh, because of the abundance of bandwidth which is available with the 5G system, we'll see some of those numerical values in the following slides. And we can say a lot of IoT applications, especially sensor-driven, a lot of these applications can take place. Then immediately we go to the right side. So this is basically how a future international mobile terminal, future IMT will look like. Okay, and you could see on the extreme right side, you're looking at a very important factor which gets married to 5G is this property called low latency communications. Okay, low latency communications. As I told you, the biggest attribute of 5G was the low latency communication, which has got so on the low latency communication, we find the we find that the latency is of the order of just 1 millisecond. That's why one of the systems which exploits this
Excuse me, sir. So your mic has been muted. Can you unmute yourself, sir?
Hello, can you hear me?
Yes, sir. That was fine, sir. Carry on.
Yeah. So at the extreme right side, we have the self-driving car, and we have the mission critical applications. especially for tele-surgeries and mission-critical e-health application which are located. Okay, then the other area which is coming up in a big way, which we want students to exploit in a big way, is the augmented reality and virtual reality. Augmented reality, for students to get an idea about it. See, let's say today somebody wants to purchase the latest Hyundai car, and we are worried about how to select it. You're not able to go to showroom, especially during this COVID-19 crisis. So sitting at home, you can use an augmented reality technique whereby 4 to 5 flavors, different colors of that car are brought to your computer screen, and using augmented reality, it gives you the complete sort of immersed presence that you're actually observing the car in front of a showroom and then taking a decision. And then, of course, we have the 3D video and the ultra high density things coming in a big way. Okay. Yeah. Chitra, can you get back my screen? Hello?
Hello?
Yeah, Chitra, my screen, can you make it big?
Sir, actually it is normal only, sir. You can proceed.
Okay. I don't know, it was coming big now. I don't know what has happened. Yeah, it's okay now. Fine.
Okay, sir. Thank you, sir.
Yeah, go to the next slide, please. Yeah. So now we come to 5G vision requirements. So we have all machines, human things are wirelessly connected by 2020. And we are looking at a figure like 25 billion connections, massive connectivity, and download speeds of the order of 10 gigabits. Okay, that means basically between the base station and the mobile subscriber. And look at the latency of the order of 1 milliseconds. And this is giving us ultra reliable and long battery life. Okay, so this is one of the greatest attributes which are coming out here. And you could see how this is being exploited in application now. Next slide, please. So 5G in 2020, and we are looking at the capacity here. And of course, we are looking at, all of us are very familiar with the Shannon's law there, the capacity, and we can reach the Airlink limit there. And if you can look at how we earlier we were restricted in the VHF to about the microwave band. Okay, the moment we come to 5G cellular, we are looking at frequencies from the order of 24 gigahertz to about 80 gigahertz is where we will look at. And one of the application bands which is of present interest is the band in 24 to basically that is from 26 to about 29 gigahertz, with a centered around 28.5 gigahertz, the millimeter wave array. And you could see the antenna which you have to have is an area where I had the opportunity to work at IIT Kharagpur, basically the phased array antenna. Okay, that will give you an example of the antenna array, and at 28 gigahertz. And this is the type of array which we would be using in the 5G communication, especially for providing connectivity with several base stations being located. Because one big problem which we encountered millimeter wave is the attenuation. So you will find a lot of these small stations to be located, and from where this whole thing has to be taken up. Okay. So this is the band, as I was telling you. Of course, at 60 gigahertz, we have an unlicensed band, and that also shows you the type of bandwidth which are available. And while mentioning about this, it's my duty to tell you about the satellite band. Please remember the KU band, KA band, the satellite band have already they are already exploiting this millimeter wave. And what is important is what they started earlier with a modest bandwidth of 54 megahertz has now got translated to about 8 gigahertz when they go into the millimeter wave. So there's a huge bandwidth available, and you could see the number of connections, especially for internet connections. I believe Elon Musk launching these Starlink satellites will also try to exploit a lot of these millimeter wave, a lot of this exploitation which are going to happen. So the bandwidth of 800 megahertz will be sufficient for them to give all the connectivity which is required on ground Earth. Next slide, please. Yeah. So now we come to 5 G standardization. Next. So as we looked at 1G and 2G, the overview of the timeline in which it is being done. So this is how it evolved. The turn of the century, we saw 3G coming in. In around 2010, we have 4G brought in, and LTE and LTE advanced. By 2020, everybody is heralding 5G, and this is the type of deployment and how this whole thing has been finalized. That is how it has evolved. Next slide. And you could look into some more details here on the timeline and processes. Under which this is happening. Okay, next slide. And this is the 5G standardization, which I was talking to you about, under phase 1, because they have to put it out very carefully, the vision, requirements, proposal, and this is basically brought out by 3GPP, which is a standardized, which is an organization which standardizes a world body, and we find all the other bodies falling in line with that, so that after going through all this evaluation and proposals, it is then able to bring in the initial 5G commercialization. So you could see how much of requirements are there before that standardization takes place. It is not something which can be immediately done. That's why we want to bring to your attention that that gap of almost 10 years is required for the systems to fall in place, and all the trials and its feasibility are first standardized before it is allowed to come on board. Next slide, please. So now comes the other big reason in 5G, where we have the advent of the spectrum requirements, the 5G spectrum requirements, as you would see, because of transcending to this new technology. Yeah. So the evolution of the cellular technology, as you see, as it went from 2G on the red line, how it has gone here, and you could see the various categories, and you can, on the left side, you could see how beautifully it combines these parameters of high bandwidth, okay, and high cost, high power, low latency, which are coming in here. And on the lower side is low bandwidth, low cost, low power, but higher latency, which you have when you come with the category of narrowband system, where basically the IoT things are requirements are trying to be exploited. Next. So when you look at the spectrum requirements, you have to address the diversified requirements for the envisioned 5G and usage scenarios. So you will find very conflicting requirements at times, but how beautifully they have enabled 5G to address this. 5G needs to access to high, medium, and low. Okay, so when you look at that, high frequencies, we had the super data layer, the medium frequencies, which are basically used for coverage and capacity layer, and the low frequencies, the coverage layer. Okay, so you will find that is basically the 5G. What we are trying to do is the sub gigahertz band, where they are trying to use it at this level. Then that is 2 to 6 gigahertz, below 2 gigahertz, but above 6 gigahertz, we are able to see that it is able to give a 800 megahertz arrangements in a contiguous way, which is made available for it to exploit a lot of these applications. Next slide, please. Next slide. Yeah. So now this triangle again gives us a magnificent way to express on the aspects of coverage, capacity, and latency. Look at it very carefully. We'll start with the blue triangle, and what it does is we uh, look at the band. This is where the millimeter band is basically concentrating from 24 gigahertz to 40 gigahertz. The first trial probably in India we are expecting to be around 28 gigahertz. Okay, and then uh, we look at mid bands where we have got a lot of experience, and this is basically the famous C band, the SNC band, with which we have been familiar with the satellite communication area, and 3.5 gigahertz and 6 gigahertz. And the earlier generation, like 4G, some of the frequencies which it has been operating, that also comes. Then mid bands 1 is from 1 gigahertz to 2.6 gigahertz, where the S band is a legacy band, and the low bands are sub 1 gigahertz is a new legacy band form. So this is basically how the coverage is going to happen. Okay. Then we come to capacity. When you look at capacity, and you could see the triangle inverted from high, it comes to moderate in terms of the capacity, and then look at the latency. Okay, the latency, you could see high capacity hotspot dense urban is where we want to give that. Moderate capacity wide area outside in coverage, okay, where we try to give it from the latency point of view. Okay? So this is very well exploited in this diagram, which is shown below here, and it shows how small cells are used, then small cells are used, and the coverage which they have on the macro cell. So how that whole thing comes in and takes on. Next slide, please. So this again gives you the spectrum allocation over time, and high bands is there, mid bands are here, and the low bands. Okay? So we would like to basically look at how we combine all this with 2G, 3G, and 4G. That is how this is being come. Next. So this gives you the spectrum geography, the carrier, the commercial services, how who are all the people involved, like the US service of T-Mobile and Sprint. Okay, they have been using this, and Orange, Vodafone, and China Mobile will come out now. Latest reports you see about 2.5 lakh BTS and 5G has been set up by China. Okay, and they are maybe every fortnight about 10,000 base stations are being put up, and that is the speed at which they are evolving on the 5G network. And Docomo and other people on the millimeter wave, Verizon, AT&T, and this is how they are able to come out with. Next slide. So 5G spectrum requirements, what is it coming? The global spectrum allocation clearly centering around 700 megahertz, 3400 to 3800 megahertz, and 24 to 29.5 gigahertz. So the global spectrum are basically thing. So depending on your application, you may go to that particular band of interest. Okay. So always we would always like to work on the lower bands, get a lot more experience on 5G rollout, then translate to the millimeter wave, where we'll be able to exploit it in a much better way. 28 gigahertz bands will be mainly used for high capacity, low latency. 3.5 gigahertz will provide enhanced capacity to mobile broadband use, and 700 megahertz is where we want to use it for IoT because of the efficient, because IoT basically exploits very low bandwidth. Acceleration of 5G deployments worldwide and Asia driven by need of reducing the cost per gigabyte and managing the exponential growth of data traffic. Next slide, please. Go to the next slide. Yeah. Okay. Next. Yeah. Now this is an application, 5G collaboration with Japan, which Professor Tariq did. So he shared with this. Okay. And we'll see. We'll go to the next one. We'll see the application coming up. Yeah. So this is basically the results of 5G field trial project which they did, and you could see the first project which they did was high definition, high realistic video streaming. Okay, that was the first project which they did, and the next one was smart city that realizes safety and security. Again, I wish to reiterate that great importance that it is not fashionable to get into projects, but we have to ensure the safety of our people as well as the security, which is very important when public sort of utilize these type of networks. Then, of course, the telemedicine aspect, which we can see on the right side. Okay, 8 kilo multi-channel transmission, remote monitoring system with high definition video here, and telemedicine between Wakayama Medical University and clinic. How beautiful, thanks to 5G and the low latency it offers. The doctors are, it's a great privilege to do a lot of their operations, the medical operations, I meant consultation, whatever it is, in almost what we say real-time type of scenarios. So that is the magnificent fallout from 5G technology. So you could see a few slides here, which gives you that. And the remote monitoring system, telemedicine between the medical university and the clinic. Next slide, please. Yeah. So this also tells you that entertainment systems, all of us are very fond of this entertainment for high-speed moving objects, whether in trains and buses, and how is it that you can realize. So here is a test environment for the train. As you know, Japan has some of the fastest bullet trains existing in the world, and to have communications being done on that type of train has been a big challenge, but here it is. Japanese, along with this, have done this. And these were some of the slides which Professor Tariq had shared with us, which I thought I could also show you. And with that, you could see the measured throughput, which are there in this. Next slide, please. Yeah. So now 5G finds the civil engineering people are very happy now. Remote control of civil engineering, construction equipment. Now they are trying to exploit using this. So this is gaining a lot of traction now, evaluated by the time required to move 3 blocks for construction, which they are able to do with this exploitation. Next. Of course, all these trials they have been doing basically because of this Tokyo Olympics, which are going to come in a big way. So entertainment in the stadium, high definition video streaming, securing safety on station premises. So all trials are being done at every level of the test environment. But unfortunately, due to this particular corona problem, all that has to be postponed now. Otherwise, we would have seen a lot of that happening now. So the experimental equipment with which they are doing all this. Next slide. Yeah, the over-the-air latency at 4.7 gigahertz. A few slides. Next. So this is the reference, Journey Towards 5G. Really thankful to Dr. Tariq, who had shared this particular thing, which I thought we would share it with you students. I think probably that brings me to the end of this session, I think, right, Chitra?
Yes, sir.
I think that comes to an end of
Yes,
my
sir.
presentation.
Yes, sir. I think we just have a few more slides, but I'll just check it out, sir.
Slides, I think. Yeah, you can go to that. Yeah, this is basically 5G vision, a unifying connectivity fabric. So what we have is the major areas: enhanced mobile broadband, multi-gigahertz data rates, extreme capacity, deep awareness, which are there, and mission critical awareness is the ultra low latency, high reliability, high availability, strong security. Okay, and massive Internet of Things is it exploits the low cost, ultra low energy, deep coverage, and high density. And we find the unified design for all spectrum types and bands from below 1 gigahertz to millimeter wave. It is 5G is able to cover this huge type of range. And very beautifully it is doing with all these type of applications which are shown below, like automotive, robotics, health, wearables, you name it, smart cities, and smart homes. So all aspects, networking, mobile device. And one area where this really stands out is in the tactile internet, which is coming out in a big way, thanks to the low latency and the reliability and the robustness which this network offers. We are able to really utilize it. Yeah, next. Yes. So there is this great feature of 5G again, is that it not only offers ultra low energy, ultra low complexity, ultra high density, extreme capacity. That means these three major things are the ones which are being exploited. First, I'll start with enhanced mobile broadband, where it looks at extreme capacity of 10 terabytes per square kilometer. Imagine when we can reach a capacity like that with 5G, and extreme data rates. They're looking at multi-gigabits per second, and compared with deep awareness, discovery, and optimization, so that it can take care of everybody. Then we are looking at mission critical control, extreme user mobility, and or to no mobility, ultra low latency as low as 1 millisecond. And please remember, our normal networks, typical latency times are of the order of 40 milliseconds. Okay, LTE maybe it's better, but the normal networks take as high as that. And compared with that, that's where I told you about tactile internet. is basically the ultra high reliability and the low latency are these two parameters which go with the tactile internet and strong security, especially we people from the government, health, and financial trusted ones are very happy when we find a network which has got strong security concepts built into it. And of course, the massive Internet of Things, which is a killer application for 5G, is the deep coverage to reach challenging locations and ultra low energy. And it's a throw off for us. That means we normally say put up and shut up the system, just insert the battery. Next 10 years, it is going to work for you in a completely fixed manner. And ultra low complexity, tens of bits per second, it can work, and ultra high density, 1 million nodes. So you could see the variations from very simple systems to very complex systems, how beautifully 5G is addressing with this diagram. Next. Yeah. So these are enhancing mobile broadband and ushering the new era of what we call an immersive experience and hyper-connected connectivity. The immersiveness is something everybody's getting in. So there you can see tactile internet I mentioned, broadband fiber to the home, telepresence is a great exploitation which they do thanks to 3D ultra high density video telepresence because of the huge bandwidth which is available. Now a person doesn't have to travel from Kuwait to India or from New York to India. The surgeon could be there and give the instruction. Magnificently, the doctors can take up the operations. And of course, demanding conditions like a football stadium when you're watching the World Cup, you could see how magnificently it can be exploited. And the broadband fiber to the home, ultra high density video streaming, and virtual reality, which I mentioned. Next. So here, connecting the massive Internet of Things, which is the killer application. So what we do is optimizing to connect anything, anywhere with efficient, low cost communication. That is the motto behind which, whether it is smart cities, smart homes, then utility metering, then we have wearables, remote sensors, and then object tracking. Okay, so that means it takes power efficient areas to low complexity to long range. So it can take up very, very different situations. Next. Okay, then we come to enabling new mission critical control services and with ultra reliable, ultra low latency communication, which is basically what autonomous vehicles, the self-driving car, which everybody's talking about, the robotics aspect, then energy and smart grid, then we have industrial automation, aviation, and medical. So it is basically trying to look at high reliability, ultra low latency to high availability coming in a big. I think that almost brings me to the end of this lecture. Yeah, this is a trial during which it has come. So last slide, this is multi-mode, multi-connectivity essential to 5G success. Please don't forget this. That means you have your 3G phones, you have your Wi-Fi, you have your 4G, whatever it is. 5G doesn't tell you, you throw away all that. Okay, 5G can work beautifully using this multi-mode device. So here how the whole thing is delineated. So we have 4G below 6 gigahertz, below 6 gigahertz, we have 4G and this Wi-Fi coming in. And then we have 5G above 6 gigahertz and we have 5G below 6 gigahertz. So all of them work together. That means simultaneous connectivity across 5G, 4G, Wi-Fi. That means, please remember, it is not 5G versus Wi-Fi, but 5G with Wi-Fi. is how this whole thing is. I think that should end the last slide.
Yes, sir.
That's the last slide.
Yes, sir.
Okay, thank you then. To the participants, sorry, I had a little bit of trouble with I had to work with my mobile. I couldn't get my tablet to work because of the connectivity problems. And I think now I'm open to a few questions if there is
Yes,
time.
yes, sir. Thank you very much for such a beautiful presentation, sir.
Thank you.
I would like to present before you a few questions from our participants. Uh,
Yes.
yes, sir. The first question, can you please tell me the cases in 2G spectrum scam? Not regarding the politics, but what was actually 2G scam?
I think it is not relevant here, so let us not talk about it. Let us go to
Okay. Okay, sir. The next question, can we use the cross-layer design of cognitive radio for 5G?
yes, it can be exploited. Cognitive radio is being used because cognitive radio is one which exploits the spectrum. You see, there is an idle spectrum. So we can very easily harness the idle spectrum and can build that feature so that because 5G has such a wide spectrum and normally this may not be a big challenge. It is a more of a challenge in 4G, but 5G because it has a huge spectrum. But then if somebody is bringing cognition, we can always exploit. It's not a problem.
Okay, so thank you, sir. The next question. Most of the research says that mobile networks affect human and environment. If so, will 5G affect us more?
Can you repeat the questions, please?
Yes, sir. Most of the research says that mobile networks affects human and environment. If that's the case, will 5G affect us more?
Yeah, a wonderful question. I would like to answer that. Okay. Uh, so basically, uh, we look at that. See, uh, right from 2G, when 2G came, mobile communication, then we went to 3G, 4G. A lot of people have been raising this question that will this mobile communication affect the human being? See, if there's a small baby sleeping in the cradle and you have some radiation coming into the house, and how is it that is going to exploit it, all this type of thing? And what is the type of radiation effects? So I basically like to look at it uh, basically the type of ionized radiation, non-ionized type of radiation, what this whole thing is about. Okay, so it depends. You see, normally these type of radiations which you have coming from the cell phone are basically under a category which does not break any bond, electrical bond like we have at X-ray type of frequencies. Okay, so maximum it would do a little bit of heating on the skin, but then the power levels have to definitely be controlled. But thanks to the guidelines given, being in India, we are able to work the radiation levels at very below that safe limit. In fact, Europe has a much higher limit than what we have. So we in India are at a much lower rate. So as of now, the radiator levels are so low, it would really not affect this type of sort of the print media is right now saying that 5G should be banned and things like that because the signal levels, because the BTS stations for 5G are so low because we have small cells are much lower than the macro cell which we have in 2G. So the signal levels are much lower, only the frequencies are higher. But we find maximum effect they have is heating of the skin. So that can be controlled. It doesn't really pierce, a little bit of heat, but that again can again be controlled. So it's not really a big problem. So nothing to be feared about.
Okay, sir. Thank you very much. The next question, which software can be used to realize NFV implementation?
Can you repeat which software?
Which software can be used to realize NFV implementation?
End-to-end implementation.
NFV, sir.
I am not
It is
able to get
capital NFV.
NFV. Oh, network.
NFV, sir. Yeah.
Okay. Network function virtualization. Oh, what? That's a lovely question. Yes. Yeah. This is really high-end software. But I think initially our people were trying to, a lot of people were initially looking at something like a C++ object-oriented type of a thing. Okay. But right now, we would look at good realization using, I don't know how many of you are familiar with the Keysight system view. Keysight has got an excellent system view software, so on which we can really simulate a lot of these things in a very big way, a complete system, right? And we can work, of course, everybody these days works with Python. Of course, that software everybody doesn't access, but those of you who are familiar on that, you could really take up and do a lot of these studies.
Yes,
Yes.
sir. Thank you very much. Shall we take up two more questions, sir?
Yeah, sure.
Yes, sir. The next one. What are the major problems India has to face when we set up 5G?
Yeah, major problems India would face is infrastructure and, of course, mental makeup. And we would not want to translate straight to the millimeter wave. We would, because we have a very rich experience at 700 megahertz and sub 6 gigahertz, and also very good experience in satellite communication. We would like to take the experiences we have from all that before we enter into the millimeter wave region. And thanks to the excellent work being done, I go back to my own alma mater, IIT Madras, which has got an excellent test bed being taken up. A lot of the 5G test beds have been done by our own Indian engineers. They've come out with excellent type of discussions and sort of dissertations which have also emanated from that, and conclusions, and they have come out with some very excellent, exciting results. And I would fail in my duty if I don't mention Professor Arogisamy Paulraj from Stanford University, who has been a key person in enabling this type of investigation to take place at IIT Madras in a big way. And a lot of my students have benefited when he was at CRL Bangalore in a big way. And Professor Paulraj, and you must remember, was the one who gave us this excellent tool for us, all of us who are exploiting his sort of capability. And he has given very good insights for us to venture into the test bed of 5G. So we are following that directions in a big way. I'm sure we are going to come out with some very exciting results. And thanks to Professor Paulraj and the group from IIT Madras, we find a lot of those inputs have been transferred to our headquarters at New Delhi. And our Honorable Prime Minister, very kind enough to take all those inputs. And we would find shortly India going in a big way to implement 5G, proving its
Yes.
usefulness.
Thank you very much, sir. One last question. If 5G is implemented, can it be used in the present devices in which we are using 4G?
Yeah, lovely question. Beautiful question. Yes, one extra chip is required. So it all depends, because a lot of these mobile phone users, can you imagine 107 versions are there in China now? They come out with 107 different models. They've got a huge thing. So people would like to exploit 5G. So they may not like to give this so easily. So you might have to purchase that 5G phone. So you may not be able to get it like an add-on. So that 5G phone is going to cost you, but it's that one extra chip which is going to make that difference. So, but there'll be a costing for it.
Okay, so thank you very much, sir. Thank you for
Yes.
answering our questions patiently. And
Yeah.
thank you for spending your valuable time on presenting such a beautiful presentation to us today, sir.
Thank you very much. And it's very exciting. I'm sorry I'm not there in front of the students to directly give them. But being very passionate about this area, we want our students to really understand that the killer application for 2G is SMS, 3G is internet, 4G is streaming video, 5G is connectivity. So on that thought, I would like to leave, and 5G to work along with Wi-Fi, not 5G versus Wi-Fi. So this is what the students have to take it from. Wish you
Yes.
all the best.
Thank you very much, sir.
Savita management for permitting me to come on this line. Wish you all the very best.
Thank you very much, sir. It's our pleasure, actually. Thank you, sir. I thank, yes, sir. I thank all the participants for joining with us today. Hope you would have enjoyed the session well. And yes, our questions have been answered by the speaker very well. I would like to announce about our upcoming webinar. It is on IT companies and its needs by Mr. Satish Kumar Paneerselvam, Project Manager DXC Technologies Chennai, that is scheduled on June 8th from 4 p.m. to 5 p.m. I request all faculties and students to attend the webinar and get benefited. Meet you all in the next session of our webinar series. The feedback link will be posted in our chat box soon. And we request the participants to fill the feedback link with the correct mail ID. The link for feedback and e-certificate is posted in the chat box and in our YouTube live streaming page. Please fill the form and receive your e-certificates through your mail. Kindly complete filling up the feedback form within 30 minutes after the session gets over. This feedback form link will not be sent either through WhatsApp or to your mail. So kindly fill it up with your correct email IDs. Thank you.